So we have access ports at the Sellafield site where we've got minimal person access arrangements that we can get into. There could be high radiation, high contamination areas, and it's a case of we need to get into those areas now to fully understand what we need to do to decommission.
So the background to this challenge was developing a bit of kit that can go into a GPS-denied pitch black environment through a 150mm bore. We've developed a UAV that will do that.
We've struggled with the innovation side because there isn't currently anything on the UK market, or in fact the worldwide market, that we can readily deploy because of the size.
We've developed a small drone that passes through a 140mm pipe. It has onboard lighting, tilt mechanism for the camera, and basically it will do a visual inspection of the entire environment. To get the UAV into the cell, we've got a deployment mechanism that holds a little scoop that holds it in place. This is passed through the bore, at which point the mechanism expands to compress itself against the bore. A solenoid is released and the drone then flies off the platform. So we've done multiple demonstrations of our technology over the past 10 to 12 months. 10 months ago, it was quite difficult to control. It was a bit too big, and we've done a lot of work in the interim, lots of new frame designs that really can constrict the outer envelope of the drone so it can fit in the bore and fly much more stably. The way we've set up the drone for a pilot is quite slow moving, so it's almost cinematography as opposed to, you'll quite often see these drones do fast flying racing.
It's not an overly complicated system, but there's not a lot on it to fail, so it is a reliable, robust piece of kit. It actually works, and the first we've seen today has been simple but reliable, and that's what they've demonstrated today. They've got the UAV in through the gap, it's flew perfectly, and then they've been able to retrieve it reliably.
They've proven that the concept really does work, and it's something that we need to be more open to at Sellafield. We look for final polished solutions when really we should just be looking for technology that will do the task.
We're really hoping that this has quite a lot of impact for the nuclear decommissioning sector, getting eyes on areas that haven't been seen for 30, 40 years, so that there can be proper asset management, improving the safety and efficiency of decommissioning.
ICE9 have been fantastic to work with. Nothing's been too much trouble, too much hassle. They've come and done a couple of trial sessions with us in the Engineering Centre of Excellence, and that's worked really well, so that we can actually say, well, this works for us, this doesn't quite work for us, and as a collaborative team, it's been fantastic.
So yeah, next stage for us is to try and commercialise this technology through Sellafield, but we'd also be happy to look elsewhere in other applications, so really just iterative improvement and get it used.